Good morning to everyone. Myself, Shaul Hamid. In this video, we are going to continue our discussion about testing. We will continue with the introduction and further important terms related to software testing will be introduced and discussed here. The contents of these video classes are taken from these two sources. I suggest you to read out the original sources for a better understanding. As said earlier in this video, we will be discussing about the various terminologies fundamental to software engineering. Understanding these terminologies will help you to gain a better understanding of software testing as a whole. The goal of testing is to show that a program does what it is supposed to do and to discover errors or defects in the program before it is put into use. Okay. The software testing process is as follows. After the program is written, you send the program for testing. When you test the software, you execute the program with artificial data. Okay, with artificial data as an input to it. Then you check the results of the test execution you made just now, and then you check it for errors, anomalies. Okay, and to gain insight about the program's behavior. Essentially, two goals are expected to be completed during testing. Okay, the first goal is to demonstrate to the customer and the developer that the software do meets its requirements. Note that developer is also included here. But nowadays, developers themselves are becoming a part of testing team. We will talk about this in the later videos. Essentially, the first goal is to demonstrate to the customer and the developer that the software indeed works. Okay. For custom software, this goal implies that there should be at least one test for every requirement in the requirements document. Okay. A test for each and every requirement which we have collected already in the SRS document. That is, each requirement should be tested. For generic software, on the other hand, for generic software, there should be tests for all the system features. In both the cases, that is for custom software as well as generic software, combination of features should also be tested to check for unwanted interaction between them. This is the first goal. The second goal of testing is to find inputs for which the software behaves incorrectly. Okay, as explained in the previous video, this is exactly same as finding a counter example to disprove a statement or a theorem. You can expect a question in this for UCT. Okay, essentially here you are trying to find defects in the software. Inputs that triggers incorrect behavior helps to identify bugs or errors in the code. Okay, inputs that triggers incorrect behavior. Okay, such kind of inputs helps to identify bugs or errors in the code. Undesirable behaviors are rooted out in this process. Undesirable behaviors are things like system crashes, unwanted or erroneous interaction between modules, data corruption, and other related things. Okay, you are essentially trying to weed out such undesirable behaviors through testing. This is the second goal. The first goal corresponds to validation testing. Okay, and the second one corresponds to defect testing. In defect testing, the test cases are designed to expose defects. During the defect testing, the test cases can be weird and obscure. Okay, here the goal is to expose defects. So in that sense, the test cases can be weird and obscure. For example, you can try to input a character into an integer variable. Okay, which is not logical to do, but you can do this to see how the system behaves in order to find defects. Okay, this is how defect testing is done, to expose defects. Testing can only show the presence of errors, not their absence. This is a very popular quote made by the popular computer scientist Edgar Dijkstra. I hope you people are familiar with the Dijkstra's algorithm. This is the same person who invented the algorithm. We have already discussed this quote in the previous video itself, but I would like to re-emphasize it again here to show its importance. Now let us discuss about verification and validation. Okay, software testing is a part of a broader process called as software verification and validation. Okay, software verification and validation is a broader process which encompasses testing. Testing is a part of it. Okay, essentially testing is a sub part of software verification and validation. The term verification and validation are often confused with each other, but they are quite different despite their similarity. As per the IEEE standards, This is the definition given for verification and validation. You can expect the question here. IEEE is a standard organization like ISI in India. Okay, you people are familiar. I hope you are familiar with ISI, which is a benchmarking organization. ISI usually defines and maintains standards. Likewise, IEEE is an organization which defines and maintains standards for technical items. Okay, according to IEEE, validation is carried out at the end of the software development. In validation, we try to ensure that the software does indeed what it is supposed to do at the end of the development. That is, to simply put, does it meet its requirements defined earlier? So does the software developed meet the requirements which we have defined already in the SRS document? Does it meet or not? That is tested through validation testing. Okay, verification on the other hand is a continuous process. At each stage of the software process cycle, all the software artifacts are nothing but the deliverables obtained after each of the phases. For example, after the requirement phase, you get the SRS document. After the design phase, you get the design document. Likewise, each of these artifacts or deliverables can be verified for correctness. SRS document can be verified, design document can be verified for correctness, so and so at each of the stages. Okay, testing is more in line with the process of verification. Yeah, testing is quite related to verification. Now let us see how validation and verification are defined in your syllabus prescribed book. As you can see in this slide, validation is about, are we building the right product? Okay, are we building the right product? Whereas verification is about, are we building the product right? Okay, take a moment and think about these two statements. On closer observation, it can be seen that the definition of verification is indeed quite straightforward. And implicitly, the definition says that verification is a continuous process and you are supposed to verify then and there at each stage. Okay, whether you are building the product correctly, you are building the software correctly, you are supposed to verify then and there at each stage of the software process lifecycle. Validation, on the other hand, is a more general process. It tries to ensure that the software meets the customer expectation. Yeah, validation tries to ensure that the software meets the customer expectation. According to your book, validation goes beyond checking conformance with the specification to demonstrate that the software does what the customer expects it to do. Okay, the ultimate goal of both validation and verification is to establish the confidence that the system is indeed fit for the purpose. Okay, in some sense, both of them are same, with subtle differences between each of them. In this slide, let us discuss about software inspection or reviews and how it is different from the traditional software testing. You can expect a question in inspection, okay, for your cycle testing. Software inspection, as the name suggests, is the process of manually inspecting the code. Inspecting essentially refers to reading out the code. It is not necessarily to read it line by line. Rather, you can gloss over the code written by others to figure out mistakes. Inspection is typically termed as a static method. Static in the sense that there is no need to execute the code. On the other hand, testing is a dynamic method where you give artificial data, that is test cases, and then run the program and observe how the program behaves with respect to the input given as test cases. But the inspection, as it is a static method, involves no execution at all. You just inspect the code without executing it. Hence, it is called as a static method. According to your book, there are 3 advantages for software inspection over testing. During testing, one error could be masked by another error. That is, a single error can mask another error. That is, the interaction between errors might lead to confusion, okay, in case of testing. But since inspection is a static method, we need not be worried about interaction between the errors. Okay, in testing, since it's a dynamic process, errors might interact with each other and this might lead to confusion. But whereas in inspection, it's a static method. So since you are not executing anything, you need not worry about the interaction between the errors. You have one less problem to worry about, at least in the case of inspection. Okay, the second advantage is incomplete systems can't be tested. Incomplete systems can't be tested because you simply can't execute it. A code which is not completed cannot be executed. Okay, you simply can't run an incomplete program. In such cases, inspections and reviews will help to find potential errors in the code. Let's say that you have written off the code, though you can't execute it, it doesn't mean that it's not to be checked. So you can inspect the code and see how good, how well you have written, though it's incomplete. Okay, the next advantage of inspection over testing is testing will only try to find and expose error, but inspection can potentially be used to check other qualities of the program, like how well the code is structured. Is it written in an understandable fashion? Is it documented properly? Is all the variable names are named systematically? And such broader code qualities can be checked only by software inspection, which can't be done through software testing. Okay, these are some of the advantages of software inspection. Thus, inspection is like a supporting process which helps in pre-identifying potential errors. So, inspection complements testing. It helps to pre-identify errors so that the testing process becomes easy. In this slide, let us see some terminologies related to errors and faults. Fault is like a mistake in a part of your code. Fault may result in a failure. Fault may lead to a failure. Failure refers to a situation where the system misbehaves. In the Ariane 5 rocket example discussed in the previous video, the register overflow is a fault. The register overflow is a fault, and the crashing of the rocket is a failure. Okay, so the overflow is the fault, and because of the fault, the rocket crashed. So a fault leads to failure. So failure occurs due to faults. Okay, errors on the other hand is defined more technically. Error refers to the internal state that the program reaches due to a fault. Okay, the internal state which the program reaches is called as error. All the three are quite the same only, but with very subtle differences. This slide discusses the test cases. Test cases are artificial input data which you give to test the program. The input data and the expected output together defines a single test cases. Okay, you specify the input and you also specify what does the output you expect for the given input. So together it defines a single test case. If you people have done competitive coding in sites like HackerRank, LeetCode and CodeChef, you will be easily familiar with test cases. If not, I suggest you to start competitive coding to improve your career. Okay, the definition of test cases can be read out from this slide. These are the 4 levels of testing. There are many types of software testing, but there are 4 fundamental types of testing. Okay, given in this slide. We will see them very briefly in this slide. Okay, unit testing is the first test you do on a piece of code. After writing a function or a small module or a class, it will be immediately subject to the unit testing by the developer itself most of the time. Okay, next integration testing is the next level where multiple modules together will be tested. This is done to discover errors that might arise due to interaction between the modules. Okay, this is one level above. You first test the individual units and then you test a group of units. Okay, a group of module to see how well it interacts between each other. And you try to weed out errors in the interaction. The third level is system testing. System testing is carried out after the software has been developed completely or nearly complete. And this testing is carried out over the platform where it will be actually running. Okay, where it will be actually deployed. Hence the name system testing. Let us say that you are developing an embedded auto voltage stabilizer. Okay, auto voltage stabilizer for a washing machine. That's an example. If you test this auto voltage stabilizer by fitting it into an actual washing machine and testing its functionality, then that is a system testing. You actually fit your piece of code or your embedded equipment into an actual system and try to weed out errors. Okay, that is system testing. Finally, the last level of testing is acceptance testing. The name is quite intuitive, where the customer comes into the picture for the first time. It is this for acceptance testing which is done by the customer themselves. Customers are asked to test the software to ensure that the demand has been met. The demand they have made, the requirement made by the customer has been indeed met. Customers are themselves asked to test this. You people might be familiar with beta releases of Android apps, where you will be encouraged to use new trial features and report bugs. This is quite similar to acceptance testing. Thus, these are the four levels of software testing. We'll be seeing them in detail in later videos. These are some additional types of testing. These may not be typically carried out for all softwares. Depending on the context, several of these testing may be used for a particular use case. I encourage you to read about all these types of testing either from your book or from the NPTEL course. This slide discusses the additional terminologies about software testing. Black box testing and white box testing are something which you will be hearing about very often in your life. The explanation should be quite obvious from the picture shown in this slide. Black box testing is nothing but the testing is carried out without caring about the internal working of the system. You simply don't care about what is there in the system. You take it as a black box. You don't care about what is inside the system, and then you test it. One need not be familiar with how the software was coded to test the software in this context of black box testing. You need not know how the software have been written. You will just test it. The testing is done with the goal to check whether the software as a whole, the software as a product, does it meet the specified requirements correctly or not. Okay, the software will be treated as a black box, and whether the black box is capable of doing what it claims. It will be tested in this context, in this perspective. Okay, whereas white box testing is, as the name suggests, is a transparent testing style where we are worried about what is happening under the hood. Okay, what is happening inside. Okay, white box testing is typically done by developers who have written the code. Black box testing aims to purely expose defects. Okay, whereas white box testing aims to expose the defects as well and gives a scope to pinpoint the source of the defect. That is, if say an error occurs, since you know what is happening under the hood, you will be able to pinpoint where the error occurs, which part of the code is wrong, is malfunctioning. So that can be identified. So that is the purpose of white box testing, and you can correct the error. So white box testing, black box testing are it complements each other, and it's necessary to understand both the techniques or methods of testing. Thank you.